Hello everyone, it's a pleasure meeting you all in my mathematics class. Today I have taken one more problem in finding the nth derivative of a function using Leibniz theorem. See, you're given y is equal to sine to the power of sine minus 1 of x whole square, and we have to prove the result 1 minus x squared yn plus 2. N plus 2 means yn plus 2 means n plus 2 the derivative of y. That is the meaning of that. This is minus is here. Minus 2n plus 1 into x is here, into yn plus 1 minus n squared yn is equal to 0, and we have to find the value of yn at x is equal to 0. So these are the two questions that we have to answer. Now, here you see that before that, let me just recall the differentiation, nth differentiation of a mixed function as u is equal to unv plus nc1 un minus 2v1 nc2 plus nc2 un minus 2v2 plus etc. plus ubn, where this un by minus 1 means n minus 1 the derivative of u, and if it is vn means nth derivative of v. So this is the understanding of the Leibniz theorem, and it is simple to prove also, but as I told you, I will not prove that. I will take up only this problem. Now, so you see that I take a first, you find out the first derivative. What is the first derivative of y1? So y is given to be like this. See, what is the first derivative? 2 into sine minus 1 to the power of x whole to the power of 2 minus 1, and differentiate sine to the power of minus 1 of x with respect to x, which is nothing but 1 divided by square root of 1 minus x square. So this is the differentiation of, see, this is the differentiation of sine minus 1 of x. This is the differentiation of sine minus 1 of x. So what is that you get here? 2 sine minus 1 of x divided by square root of 1 minus x square. You cross multiply, then you will get y1 into square root of 1 minus x square is equal to 2 sine x. So keep that, you call that as your result number 2. Then I am taking y is equal to sine minus 1 of x whole square as 1, and this is my result 2. Finding y1, that is y1 into square root of 1 minus x square, it is equal to 2 sine minus 1 of x. Then differentiate it again with respect to x. See what is I have done here? Differentiate this again with respect to x. Then square root of 1 minus x square into differentiation of y1 is y2. Y1 means what? dy1 divided by dx1 dx, dy1 divided by dx. That is nothing but your d squared y1 d squared y divided by dx squared. So this is square root of 1 minus x squared into second derivative of y, that is nothing but your y2, plus keep this y1 as a constant, then differentiate this square root of 1 minus x squared. When you differentiate it is, so that is 1 minus x squared whole to the power of half minus 1 into differentiation of minus x squared. So this is a simple differentiation. You have to differentiate this square root of 1 minus x squared as a whole, and then differentiate minus 2x. So if you do that, see here you will get 2 and 2 will get cancelled, giving you x, and this minus into plus will be minus. So you will be left with what? So you are having this, see, square root of, this is square root of 1 minus x squared, y2, then this is minus xy1 divided by square root of 1 minus x squared is equal to 2 into, what is the differentiation of sine to the power of minus 1x? It is nothing but 1 by square root of 1 minus x squared. Now you find that this is the LCM, or the denominator is this. So you multiply by square root of 1 minus x squared. When you do that, square root of 1 minus x squared into itself is 1 minus x squared into y2 minus x into y1 is equal to, so this, when you multiply this by square root of 1 minus x squared, they will get cancelled, giving you what? 2. So what is the result that you get? It is 1 minus x squared. So this is the ultimate result that we get. This is a very, very important result, and call it as 3. So I have found what is my y1 and what is my y2, and while finding the y2, I am getting a relation of the type 1 minus x squared into y2 minus 2. It is not 2, it is xy1. See, it is xy1. It is xy1 is equal to 2. Call that result as 3. Now apply Leibniz theorem here. I will apply Leibniz theorem. See here, 1 minus x squared into yn plus 2 plus this is nc1 into yn plus 1 into differentiation of this 1 minus x squared. Differentiation of 1 minus x squared is minus 2x plus nc2 is n into n minus 1 divided by factorial 2 into yn into differentiation of minus 2x is minus 2 minus you have to go for the nth derivative of xy1. So if you differentiate this with respect to x, y1 is differentiated n times, that is yn plus 1 into x plus n into nc1 n into the next derivative of this yn plus 1, then you have to differentiate the next one is yn into differentiation of this x. That is, I am applying this mere application of the Leibniz theorem. So x yn plus 1, next will be yn, but you have to you will differentiate this x with respect to itself. So it is x into, see here it is x into nth derivative of y1 will be yn plus 1 plus nc1 into the, that is the yn plus 1, the next derivative will be yn, that will the derivative will be reducing, yn, then yn minus 1, yn minus 2, it will be reducing. The other one we have to find the derivatives, the derivatives go higher. So here it is x, the next it will be what? Take the derivative of x again, but the derivative of x is, differentiation of x with respect to itself is 1. Therefore we get, here if you want I can put this as into 1. So it is n into y1 is equal to 0. Then what I do is I collect the coefficients of yn plus 2, yn plus 1 and yn. So when I rearrange the things, I get 1 minus x squared into yn plus 2 minus x yn plus 1, 2n plus 1 minus n squared yn is equal to 0. So this is the result that I want. See, what is this result? It is minus 2n plus 1, x yn plus 1 minus n. So this is the ultimate. So this result is very, very important. So this is very, very important. So this is your nth derivative. This is your nth derivative of y, where this y is this one. Now after that we have to find what is the value of yn at x is equal. That means yn 0. We have to find yn 0 is equal to what? So this is what I should find. Now from this, say I will first of all find out what is my y of 0. See, what is y of 0? That means y of 0 means put x is equal to 0. Sin 0 is 0. So y0 is 0. Using 1. Then come to this y1. y1 is equal to, see, can you see this y1? Put x is equal to 0. y1 of 0, this is 0. Therefore y1 of 0. Again x is 0. So 2 sin 0. Sin 0 is, sin minus 1 of 0 is again 0. So you see that here you will find y1, see, y1 of 0 is equal to 0 using 2. So using 2, I am getting y1 of 0 as 2, 0. Come to this y2. Where is your y2 here? I have got here my y2. Put x is equal to 0 here. So when you put x is equal to 0, this is 0. So y2 of 0, this is 0. Therefore, y2 of 0 is equal to 2. See, from this relation, from this you can find y2 of 0 is equal to 2. Because if you put x is equal to 0, this is 0. y2 of 0, this is 0. Therefore, y2 of 0 is equal to 2. So y2 of 0 is equal to 2 using 3. So I got. Now, after getting, see this part, you get rid of this. Then we will come to 1. What is my yn plus 2? Come to this. What is my yn plus 2 of 0? What is my yn plus 2 of 0 here? See, here, can you catch it? See, this is your result. In this, you put x is equal to 0. So, this will be 0. This part will be 0. And therefore, you will get yn 0. So, from this, you will get yn plus 2 of 0. See, from this, you will get yn plus 2 of 0. Then this is 0. Therefore, 1 into yn plus 2. X is equal to 0 means whole thing becomes 0. Minus n squared yn of 0 is equal to 0. So this implies yn plus 2 of 0 is equal to n squared into yn of 0. This is a very important result. This is a very so that is what I have written here. See, this result is very important. This result. From this we get. Now, you start finding what is your y3. What is your y3? y3 is y2 plus 1. But y2 plus 1 is nothing but, use this relation. y2 plus 1, see, it is n plus 2. Yes, here I'll write it as 1 plus 2. Okay, this is 1 plus 2. 1 plus. So, it is yn plus 2 is equal to n squared. See, this is n squared into yn 0. Use that relation and start writing the values. y3 0 is equal to y 1 plus 2 0. But using this, what is in the place of n? 1. So 1 squared into y1 0. Because n is equal to 1. So 1 squared into y1 0. But what is your y1 0? See, y1 0 is 0. y1 0 is 0. Therefore the whole thing becomes 0. So y3 0 is 0. So this one y3 0 is 0. Now let us come to y4 0. What is your y4 0? Here you will find this. y4 0 can be written as n. n is 2. 2 plus 2. Therefore 2 squared into y2 0. But what is your y2 0? y2 0 is 2. Therefore you get 2 squared into 2. Because y2 0 is equal to 2. So what is the value of y4 0? y4 0 is 2 squared into 2. Okay. Then we will come to 5. y5 0 is equal to, see, n is equal to 3 here. I will write it here like this. 3. So this is your n. So this is n squared into y3 0. But y3 0 has been got to be 0. Can you see this? See, where is your y3 0? See, y3 0. y3 is 0 is 0. Therefore, this 3 squared into y3 0 is 0. So you can find that y1 is 0, y3 is 0, and y5 is also 0. See, can you see here? See, y3 is 0, y3 is 0, y1 is 0, and y5 is also 0. So, y1, y3, y5, you will find y5 dot dot everything will be equal to 0. That means for n odd, everything will become 0. Now let us come to what is our 6. y6 0 is, you can write this as 4 plus 2. So this is nothing but your 4 square y4 0. But what is your y4 0? 2 square, see, 2 square into 2. So your y6 0 is y4 plus 2 0, which is equal to 4 square, y4 0, that is 4 square into 2 square into 2. That is using, can you see this here? y4 is 2 square. But this is 4 squared comes because it is 4 squared into y4 0. Therefore you get 4 squared, 2 squared, 2. So I am getting, see, this is not 0. So y2 0 is not 0. Where is your y2 0? See, y2 0 is not 0. Here y2 0, can you see this? y2 0 is not 0. And y4 0 is not 0. And here you find that y6 0 is not 0. So that means y2 0, see, y2 0, y4 0, y6 0, y8 0, all these things are not equal to 0. They have values. That means, now let us come to this. So y6 0 I have written here. So you will find that y8 0 also I have written here. What is it? y8 0? y6 plus 2 0, that is 6 squared into y6 0. But what is your y6 0 here? Where is your y6 0? It is 4 squared. So 6 squared, 4 squared, 2 squared, 2. So you see that this pattern goes on. That means here if it is 8, that is 6 plus 2, that means 6 squared into 4 squared into 2 squared into 2. And if it is 10 squared, what will it, if it is 10, y 10 0, what is it you will get? Here you will get it as 8 squared, 6 squared, 8 squared, 6 squared, 4 squared, 2 squared and 2. So if you observe closely, we are getting a pattern of writing. What is that? Y and 0 will be equal to, if it is 8, it is 8 minus 2. It starts with 8 minus 2 squared, then reduce everything by 2. 8 minus 2 is 2 whole squared, then 8 minus 4 whole squared, something, it goes on like this. So you can find that, you can write this as n, then immediately you must have n minus 2 whole square. Then n minus 4 whole square. Can you observe this? 8 means 8 minus 2 whole square. See, 8 minus 2 whole square is 6 square. Then 8 minus 4 whole square. Then 8 minus 6 whole square. Then 8 minus, this is 8 minus 8. Here 8 minus, you will get 8 minus, see, you will get it as 8 minus 2, 6 square. 8 minus 4 is 4 square. 8 minus 6 is 6 square. And then you have got this y of 0 is equal to 1. So y of 0 is equal to 2. See, we have got this result. See, y2 of 0 is equal to, when y2 of 0 will be equal to your 2, therefore we get this result. So you see that there is a pattern of writing. So if you follow closely how this is written, using that pattern I can write y and 0 is equal to n minus 2 whole square, then n minus 1 whole square, then n minus 6 whole square, then n minus, so slowly it gets reduced, and finally at one stage you will end up with only these numbers, 6 square, 4 square, 2 square, 2. So this is the pattern. Can you see this? Therefore y n 0 will be equal to n minus 2 whole square into n minus 4 whole square into n minus 6 whole square into n minus 8 whole square. Like that it gets reduced and reduced and reduced, and finally you must have all these numbers, 6 square, 4 square, 2 square and 2. So therefore you find that for all n even, when n, see here n is even, see, n even, n even. So for all even values you are having values. For odd it is 0. So for the odd it is 0. Say I have written here y1, y1, y3, y4, y7, y9, everything will be 0. Whereas you will find that y2 has value, y4 has value, and y6 has values, y8 has values. Therefore, in general, your n, when n is even, it will be having values, and its value is given by say. Therefore, I have written y and 0 of 0 is equal to 0 when n is odd. But if it is y and 0 when n is even, you must write it as n minus 2 whole square into n minus 4 whole square into n minus 6 whole square, dot dot dot. It goes, see this pattern I know, 6 square, 4, even 8 square will be here, 10 square will be here. So you can write it as 6 square, 4 square, 2 square and 2, and you get this result. Okay, so this is usually found. So this value of this is also found. So this is yn of 0, so its value is, you have got this value as here, see, this value is, you have got it here, yn of 0 is equal to this. I hope that you have understood that. And here it is, you have to find the first two derivatives and then apply the Leibniz theorem. Then you find y0, y10, y20, find what is happening, then you can go for y30, y40. Using a particular pattern, you will be able to end up with a result telling you that for odd values of n, yn0 is 0, but for even values, it is having values as yn0 is equal to n minus 2 whole square into n minus 4 whole square into n minus 6 whole square. It goes on up to 6 square, 4 square, 2 square and 2. I hope this you have understood. We'll see more problems in the coming days. Thank you.